Hello student, I am Deepak Saini and we are discussing the kinematics, right? The distance and the displacement is our topic and this is our first question. In the first illustration, this is the example number 1, right? The question is particle start from origin, goes up to the x point 20, 0 and the return back to the same line to the point minus 20, 0, right? You have to find the distance and the displacement in this case. So what is the question? Suppose if this is the origin and this is the 20, 0 is the on the x-axis. So this is the first position O, then this is the A. The particle moved from O to A. So what is the distance covered by the particle is the 20 meter, and then it returned back to the point B, right? And this point B coordinate is minus 20, 0. So here you have to find the distance and the displacement. Distance is nothing but the path length covered during the motion, and the path length is OA plus AB. So this is the 20 meter and this is also the 20 meter. So the distance is OA plus AB. It is equal to 20 plus 40. The distance covered is 60 meter, right? And what about the displacement? The displacement is nothing but the line joining initial to the final position. If this is the initial position, this is the final position, and this is the displacement. So displacement is OB, which is the 20 meter in the negative x direction. In negative x direction. So this is the answer. Also, this is the second question in which the distance and the displacement you have to find, and this is the figure of the question, right? You start from O to A, it moved for the 8 kilometer, then A to B, right? This it moved for the 4 kilometer, then B to C, it moved the 4 kilometer again, and finally it reaches the point D, and this point D as the 1 kilometer, right? So in this case, what is the distance? You tell. The distance is nothing but the path length covered during the motion, that is O to A, OA plus AB plus AB plus BC plus CD, right? This is the 8 plus 4 plus 4 plus 4 plus 1 kilometer. So this is 8 plus 4, 17 kilometer is the distance, right? And what about the displacement? The displacement is nothing but, what is the displacement? Is nothing but line joining initial to final position. So how to find the displacement in this question? Listen one thing. If you consider this the triangle, right? So this is the 8 kilometer, right? And this is 4 kilometer. So what is this distance? This distance is 4 kilometer. Also, if I want to find this distance, the whole distance is 4 and this is 1. So this is the 3 kilometer, right? So in this triangle, the base and the perpendicular we know, and this is the displacement. So the displacement D is represented by a root over 3 square plus 4 square. This is the 4 square, this is the 3 square. Right, and this is the 5 kilometer. So the displacement in this question is 5 kilometer. All right, question number, this is the illustration number 3 is over given. What is the question? The particle goes go along the quadrant of the circle of the 10 meter. So if this is the circle, suppose, right, the radius is 10 meter, right, from A to B, it goes like this, it reaches to the point B. This is the y-axis and this is the x-axis, right? You have to find the displacement and the distance and angle between displacement vector and the x vector. So if this is the this is the circle of the radius r, so the distance is nothing but, what is the distance? Is equal to path length, and this path length is nothing but 2 pi r. 2 pi r is the total circumference divided by 4, because this is the one quadrant. So pi r by 2, and this the pi radius is 10 meter. This is the 10 meter upon 2. So the 5 pi meter is the distance covered by the particle. All right. And the displacement, what is the displacement you tell? The displacement is nothing but the line joining initial to final position vector, and this is the displacement vector. This is the distance, and this is the displacement. If this is r, this is r. So what is the magnitude of the displacement? The displacement is the AB vector, and its magnitude is equal to, this is r, this is r, hypotenuse 90 degree it is. So the hypotenuse will be equal to root over r square plus r square is equal to r root 2, right? So r root 2 is equal to 10 root 2 meter. So this is the magnitude of the displacement. And what is the angle between the x-axis and the displacement vector? So if this is r, this angle will be 45 and 45 because it is an isosceles triangle. So this angle theta, what is the angle theta? Angle theta is equal to 180 minus 45 is equal to 135 degree from positive x-axis, right? So this is the solution. This illustration, right, what we have, the motorcyclist follows a track which is of the shape of the hexagon, right? And after 500 meter it turns by the 60 degree. That is the cyclist or the motorcyclist is moving in the hexagon. I am explaining the question. The motorcyclist start from point A and it move for the 500 meter, and then it turns by the 60 degree like this, and it reaches to the point B again, and again it move to the 500, right? Then it turns by the 60 degree to its left like this, then 500 meter, then like this, and so in this way, the motorcyclist is moving along the direction of the, along the side of the hexagon, right? The side of the hexagon is given as 500 meter. So what you have to find? Compare the magnitude of the displacement with the total path length covered by the motorcyclist in the each case, right? Specify the displacement of the motorcyclist at the third, sixth, and the eighth second. So this is the first second. If we start from t is equal to 0 over here, the first second over here, right? T is equal to 2 second over here, and t is equal to 3 second over here, right? 5 second or 4 second over here, the 5 second over here, and this is the 6 second over here. This is the 7th second comes to the this point again, and this is the 8th second comes to the again, right? So the listen one more thing. I'm giving you the concept about the hexagon, right? If the side of the hexagon is a, right, and you will see the hexagon mean the every angle is of 60 degree, the every angle. So all the triangle you are looking, yeah, in this figure is of iso equilateral triangle. So angle is equilateral triangle, so all the side is a, right? This is a, this is a, so all the sides are a. Now this length, suppose this the biggest diagonal present in this hexagonal. So if this is a, this is o, a, b, I'm assuming c, o, a, b, c. So the biggest diagonal is the oc, which is a plus a is equal to 2a. Are you getting or not? All the diagonals are of length 2a. Now if we consider this is the diagonal, this is the length, this is the another length. If this is a, this is a, this length OB, which is equal to OBD, OABCDE, right? So DO, OB, OB is equal to BD is equal to what? DO. R of equal to a root 3, right? This can be proved, right? This can be proved, but you remember, if this is the a, so this length is what? A root 3. If this is equal to a, and this is also equal to a root 3, and this is also equal to a root 3. All the lengths are equal, and if one side of the hexagon is a, then the length of this is the a root 3. Are you getting or not? This is the a root 3. So the first second, at first second, right, what is the distance? The distance I'm writing here, the distance and the displacement. All right, this is the displacement. So at the 1 second, the distance and the displacement both are equal, the 500 meter and the 500 meter it is, right? At the first second, at the third second, okay, at the third second, this is, so the distance is 500 plus 500 plus 500, that is the 1500 meter is the distance, and this is the displacement. The displacement is 2a, 2 into 500, that is the 1000 meter. So 1000 meter is the displacement. Are you getting? Now, if we consider the 6 second, this is the 1, 2, 3, 4, 5, and this is the 6 second. So, at the end of the 6 second, what is the distance? 500 plus 500 plus 500. So, that is the 6 into 500 is equal to 3000 meter is the distance. But at the end of the 6 second, the particle reached to its original position. Therefore, the displacement is 0 because the initial and final position are coinciding. Therefore, the displacement of the particle will be 0. Now, if we find at the end of the 8th second, this is the 7th second, this is the 8th second. So again, the distance will be this plus this and 500 plus 500, right? So the distance will be 8 into 500 is equal to 4000 meter. And what is the displacement? Displacement is a root 3, line joining initial to the final position. A root 3 means this is the 500 root 3 meter is the displacement for the question, right? So you will understand the biggest diagonal of the hexagon is 2a, and this is the length of the in the hexagon, it is of a root 3. Although we can have this form, you can remember this formula, a root 3, this is the length, a root 3. How does it come? I am explaining, right? If you consider this the a and this the a, right? This is a and the angle is 60 degree. If this is a, this is a, right? And this distance you have to find, suppose, right? What is the angle between them? Is the 60 degree. So you may consider the vector addition. The d is what? Root over a square plus 2a into cos 60, right? If you simplify this, you will get a root 3. So you can remember this length of the hexagon is to be the a root 3. This is the very first question, and in this question, particle move along the circular path of the radius r. It complete one revolution in 40 seconds. Calculate the distance and the displacement. Suppose a particle is moving in of radius r, all right, and it complete the one revolution in 40 seconds. Are you getting? What is the total time? The total time we have t is equal to the 2 minute plus 20 second. The 2 minute mean 120 second plus 20 second. Listen one thing. One revolution is completed in 40 second. What does it mean? This is the 40 plus 40 plus 40 plus 20. It means this is the one revolution, this is the one revolution and half revolution. One revolution, one revolution, one revolution and half revolution it is completing. So in 40 seconds it start from here, it move like this and complete the one revolution in 40, then 40, then 40. So 3 revolution plus 20 seconds. So if start from here and it reach to the point B, diagonally opposite to the initial point. So it cover the 3.5 revolution in time 2 minute 20 seconds, right? So in this case, they are asking the distance and the displacement. So the distance will be equal to what? 2 pi r in the one revolution plus 2 pi r plus 2 pi r plus pi r. So this is equal to 7 pi r, 7 pi, and the radius is given as the r. So this is the distance covered during the 2 minute and the 20 second. All right. And what about the displacement? As you know, the displacement is nothing but the line joining initial to the final position. If this is r, this is r. So this displacement, which is equal to AB, is equal to 2r. So this is the answer of this question, right? Okay, so in this question, in the question number 2, we have a circle, and uh, you can read the question. The radius of the circle is 200 meter, and this is the starting point P and the diametrically opposite point Q. The three girls has to reach by the three different path. Suppose this is the path A, this is the path B, and this is the path C. Are you getting or not? So they are asking what is the magnitude of the displacement for each. So what is the displacement? The displacement in each case will be equal to what? Line joining initial to the final position. So this is the displacement. This is the distance in path 1, path B, path C. But the displacement in each case will be equal to AB, which is equal to 2R. Are you getting or not? And they are also asking for which girl it is actual equal to the length of the path. So if you see, this is the path which is the same as the distance and the displacement. So the path B, for path B, the distance and displacement in magnitude are equal. So this is the answer of this question, right? Okay, in the next question, there's a wheel of radius r, right? This is the wheel of the radius r, and this is the point P over there. If we start rolling without slipping, complete half a revolution, find the displacement of this point P. Suppose this is the ground, and when the radius is capital R is given in the question, right? So you have to find the displacement of this particle P when it completes the half revolution. And you tell me, when this wheel is rolling on the ground, when it complete the one revolution, so when it complete the one revolution, the point P will come over the ground again. Are you getting or not? And this is the center to center distance. So what is this distance? This distance of the circumference is 2 pi r. So can you tell me, in one complete revolution, the center to center distance or this distance will be what? It is nothing but equal to the circumference of the particle, right? The circumference of the sphere, right? So this is the one full revolution. In the half revolution, this point will reaches to the highest point of the motion, right? When it move like this, so the particle P reaches to the highest position. So this is the half revolution. So this distance is pi r, right? And this distance will be equal to what? 2r. So you have to find the displacement of the particle P. Line joining initial to final position is the only displacement. So this is the displacement of the particle P in the half revolution of the sphere. So the displacement is what? Displacement is equal to a root over, this is the base, this is the perpendicular, and the hypotenuse we can find pi r square plus a 2r square. If you take the r common inside the square root, you will have this. So this is the displacement and the solution of this question, right? Okay, in this question, a man moved 4 meter along east, then 3 meter along north. After it climbs a pole of height 12 meter, we have to find the distance and the displacement. Suppose this is the east, right? Although we make the direction east, west, north, south, but this is the question where the three-dimensional figure we have to make. So I'm making this is the east, this is the west, this is the north, and this is the south, right? And this is the upward direction, this is the downward direction. In the first 4 meter towards east, it is the initial position. So this is the 4 meter. If this is the east, this is the 4 meter and reach to this point. This is the 4 meter. Then 3 meters along the north. So this is the north. So it reaches to the point B, and this is the 3 meter. So on the ground, and here is the pole. So what is the length of the pole? The length of the pole is 12 meter, or the height of the pole is 12 meter. And finally, it reaches to the point C. Are you getting or not? This is the north, suppose like this. So you tell me what is this distance. If this is 4 meter, 3 meter, so this hypotenuse I assume to be x, or root over 4 square plus 3 square, which is equal to 5 meter, right? And this is the 5 meter, and this is the perpendicular. So on the ground the displacement is 5 meter, then there is a pole of the 12 meter. So the line joining initial to the final position will be the displacement. All right. So what they are asking first, the distance. What is the distance? The distance is OA plus AB plus AB plus BC. The 4 plus 3 plus 12, right? 7, the 19 meter is the distance. And what about the displacement? The displacement is the shortest distance between the initial and the final position, or the line joining initial to the final position. If this is the 5, this is the 12, so this is the perpendicular, right? The right angle triangle. So the displacement is nothing but, which is equal to the OC, right? And it is root over 5 square plus 12 square. So this is 25 plus 144 is equal to root over 169. So the displacement is 13 meter in this case. Are you getting? Okay. A person move in this question, person move a semicircular track of radius 40 meter. So a person move in a semicircular arc or the semicircular track of the radius is 40 meter. If we start from one end and reaches to the other end, find the distance and the displacement. So the distance in this case is nothing but the path length, and the distance is the pi into r. This is the path length, this is the and this is the displacement. From A to B, this is the displacement. Pi into 40 is equal to 40 pi meter. And what about the displacement? The displacement is nothing but equal to 2r. 2 into 40 is equal to 80 meter is the displacement. So this is the very simple question. All right. Okay. And in this question, a man has to go 50 meter due north, 40 meter due east, 40 meter due south to reach a cafe from his. You have to find the distance and the displacement, right? Suppose this is the east, this is the west, north, and south. Initially, this is the position. A cafe, this is the cafe. Suppose this is the cafe, the 50 meter due north. This is the 50 meter. Oh, suppose this is the A to B. This is the 50 meter due north, right? 40 meter due east. This is the 40 meter, and it is the C point, and 20 meter due south, and then it moves to the 20 meter and reaches to the point D. You have to find the distance. This is the initial position where the cafe, and at this position is the home. So the distance covered by the particle is equal to AB plus BC plus CD, which is equal to 50 plus 40 plus 20 is equal to 110 meter is the total distance. But if you want to find the displacement, the line joining initial to final position will be the displacement. All right. If this is the displacement, this is the 40 meter. If this is the 50 meter and you subtract the 20 meter, the remaining thing will be of equal to the 30 meter. So what is the displacement? The displacement, which is equal to AD, right? This is the AD, and this is the right angle triangle, right? A root over 40 square plus 30 square, which is equal to the 50 meter. So the displacement of this of the person is 50 meter, and the distance covered by the particle will be the length, path length, which comes to be 110 meter.